Hi.
It's okay.
I don't know.
So then you just add them together, right? Yeah. So 36 plus 81.
Good morning, ladies and gentlemen. I hope everybody is doing well. Today's warm-up was intentionally designed to be beyond what you've seen and experienced so far. One of the things that we do in this class is stretch. We stretch our minds. And so what I was asking you to do was stretch your mind. But in a case like this, today's warm-up is not really a quiz kind of thing. It's more of an experience to try and see how far you can stretch your mind. So try not to think of today's warm-up as right and wrong. Try not to think of it as I did great or I did badly. Try to think of it as how far were you able to stretch your mind? Also, there's more than one way to express the answer. So do not, you should have your colored pen in your hand, but do not mark your paper yet. I'm going to reveal the best answer, but then I'm going to listen to what you have to say, and I'll tell you whether or not you stretched far enough to get an acceptable answer. And then we're going to talk about a couple ideas that we didn't talk about last time. All right? So let's start with number one, and let's get some answers from some people using equity to make sure everything is going fairly in my room. So number one, what did you get? I got student 8, 21, 14, and 19. Student number 8, what did you put? Student number 8 is not here. Student number 21. Say what you can.
1/5 8 to the 20th power 5 times 5 to the 4th power.
Wonderful. Okay. Student number 14, what'd you put?
I got 0.008 h to the 64th power.
Okay. Student number 19, what'd you put? Okay, so we got a few different possibilities. The best answer is 5h to the 20th. Do not mark yours right or wrong, unless you, well, if you got 5h to the 20th, of course, mark it right. But don't mark it wrong. We'll talk about other possibilities in a moment. Number 2, what did you get? I got students 7, 16, 11, and 2. Student number 7, what'd you put?
Negative 324 s to the 12th power times t to the 14th power.
Okay, and student number 16? Not here. Student number 11?
Negative 6 to the 2nd power, s to the 6th power, t to the 2nd power. Yeah.
Okay, and student number 2, what'd you put?
117
Okay, so it is 26,244 s to the 12th, t to the 14th. If you got that exact answer, of course, mark it correct. If you did not get that answer, don't mark it wrong yet. So now, I don't want to talk about the numbers right now. So I'm going to take the numbers out for a moment. And then we're going to talk about how I wanted you to be able to stretch. So I'm going to take the numbers out so we can focus on what you are allowed to do. Okay? Let's talk about number 2, because I think it's an even better example of it. So most of you did a good job by doing power of a product. You took the 2 and you applied it over there, you applied it here, and you applied it here. Okay? We took out the numbers, so we're not going to worry about that. You did s to the 3rd to the 2nd, right? S to the 3rd to the 2nd. Some of you did not follow my advice, and it tripped you up. Times. Now we have t to the second, t to the second. Now, here's something that you need to understand. What's going on with this whole thing and this whole thing? What is happening to those two expressions? Danielle? Yeah, there's a big multiplication dot right there, which means that this is being multiplied by the result of this, here and here. This is now s to the second to the third power, s to the second to the third power, times t to the fourth to the third power. Cameron, does this look familiar? Kind of? You didn't have that on your paper somewhere?
Yeah, I did.
Okay, because when you said your answer, you said you kind of started and then it sounded like you stopped. I don't know if you actually read me everything that was there. So the next thing we have to do is power of a power, my favorite property ever. Power of a power, power of a power, and it sounds like a lot of you got that. Because I walked around and I saw a lot of s to the 12th. So we've got s to the 12th times t to the second times s to the 6th times t to the 12th. Give me a thumbs up if you've got that. Okay, Selena, you didn't have that? I mean, I'm not talking, I know there were numbers here too, but did you have those pieces in? It's okay if you didn't. Okay. So now people stopped. But now I want, one second, Kayla. So now I want to point out something. So let's take a quick little side trip. Let's come over here. And we've talked about this before. 2 times 3 times 5. Could you mentally do that for me, please, right now? Mentally. Give me a thumbs up when you got it. Okay, Kyra, what is it? It's 30, okay? So now, what if we did this? 3 times 2 times 5. Can you mentally do that, please, for me? Give me a thumbs up when you got it. Okay, Jazz, what is it? 30. So they're both the same, right? Which means that if you have a multiplication problem, you are allowed to take the numbers being multiplied and rearrange them, does it not? And this is something we've talked about before, and this is something you've known for a long time. You can take the 2 and move it over here, right? And you can multiply it this way. And no matter what, you will get 30, correct? So now I want you to look back over here. And I want you to look at this. I want you to look at this. Let's see if I can do this. Oops. What if I took this, now let's do this one. What if I took this and put it over there, and I moved that over there? What can you do with s to the 6th and s to the 12th that you learned a couple of lessons ago? What are you allowed to do with those, Caesar?
Add together.
Add what together?
The exponent.
Yeah, because it's the same base being multiplied. So now you've got s to the 6th times s to the 12th. That's s to the 18th power. What did I do? I made a mistake somewhere? Oh, I put s to the, this is supposed to be a 6. I went too quickly. Sorry about that. So, thank you. So that was supposed to be a 6. I apologize. So that's not right. So let me fix that. So this was supposed to be a 6, and then of course that's s to the 12. Thank you. So, but the point was, regardless of my small error, the point is you can rearrange the multiplication problem, and now you should be able to see that this comes over here, and what can you do with t times t? Cameron?
Add them together.
Add what together?
The exponent.
Yeah, and you got to put in that word, because we're not adding the t's together. It's a shortcut to add the exponents together, and so we get t to the 14th. And now put it all back together. So this comes back together with this. S to the 12th, t to the 14th. Anyone have any questions? Kyle? We're going to get that big number, okay? So we'll talk briefly about the number. Kiara, you did beautifully well, and I believe you got the s to the 12th, t to the 14th. Do you know why you got the number wrong? You don't know why? What's 9 to the 3rd power?
27. Wait, 36. Wait. 27. Oh.
9 to the 3rd power is not 27, and that you are hardly the only person who did that. Because when you take power of a product and you do this, you did 9 to the 3rd power, and so Kyle, pick up your calculator and do 9 to the 3rd power. 9 times 9 times 9 is not 27. It's very different than that, isn't it? What is it, Selena?
729.
729. That's a big difference, right? So unfortunately, Kara, you did awesome, except you got fired from your job. And that's not what I want for you, so we got to be careful. Can't accidentally do exponents incorrectly. You have to know what you're doing, okay? So that's 729, and what's negative 6? What's negative 6 to the 2nd power? Julia? 36. Everyone pick up your calculator and do 729 times 36. What do you get? 26,244. Julian?
So you so when you're doing that kind of distribution, you actually have to do it. You actually have to solve it.
If you wrote negative 6 to the 2nd power, 9 to the 3rd power, s to the 12th, t to the 14th, you absolutely mark it correct. Okay, so that's what I was getting at, is that I didn't talk to you yet about doing the numbers part. Okay, so absolutely that is fantastic if you were able to do that. And that's what I'm talking about stretching. Okay, I hope you paid attention to what she said because that was really important. Anyone else have the same answer that she has? Okay, then you should mark it correct. Good. Any other comments, questions? So, today is part 2. And so now we're going to start taking everything we've learned so far as powers and the properties and building on it, adding to it, incorporating some new ideas. There are going to be some things today that don't make sense intuitively. Intuitively means your gut feelings, your gut instincts, your understanding of how the world works is going to conflict with what I show you. And so when that happens to humans, we tend to be resistant to the idea. When you're resistant to an idea, you don't want to do it, you don't want to deal with it, etc. But I assure you that as you give it time, it will start to make sense. As we experience it in some different contexts, it will start to make sense. You're going to have to be patient. Okay? I promise you, I've done this for 9 years. I know what I'm talking about. It probably will be a struggle today, but it will start to make sense. I promise. So, what am I talking about? Today we're going to start exploring zero and negative exponents. And you were introduced to this the other day when we did a short exploration. And the exploration didn't go exactly the way I was hoping it would go, and I'm going to redo some of it with you today, just a little bit of it. Zero as an exponent is a simple idea that doesn't really make sense, but it's very simple. It doesn't intuitively make sense. I'm going to explain why, and you're going to experience it. But it's simple. Negative exponents, much more challenging. But I'm going to teach you some techniques, and if you follow the path that I set forth for you, you will understand. But you got to listen to what I'm saying. So for example, it's been a few days since we've done a math lesson, and the last math lesson, I asked you when you write down an expression to put the multiplication dots in. And as I walked around during the warm-up, not many students were doing that. Now, I don't know if that's a case of you didn't digest what I had asked you to do, or it's been too many days since you did it. Doesn't matter. But starting today, moving forward, when you write an expression that we're going to have to simplify, and there's multiplication involved, put the multiplication dots in. I guarantee it's going to help you tremendously. So, let's talk about the easy part. Anything to the 0 power. Anything to the 0 power is 1. That is very difficult to understand conceptually, meaning the idea in your brain, well, why? Why would something to the 0 power be 1? 4 to the 0 power, well, shouldn't that be 4? Why would it be 1? That doesn't make any sense. Where does the 1 come from? Negative 9 to the 0 power, well, shouldn't that be negative 9? Or should it be 0? Why would it be 1? That doesn't make any sense. But it actually does make sense. You have to look and explore a little bit, and we're going to get to that in a minute. So I'm going to jump to something, and I'm going to come back here. So if you're missing something, don't worry about it. You'll fill it in. I mean, it's not really a whole lot to write. So now I want to jump to this, and you saw something similar to this. And what I would like you to do is quickly across your paper, write 16, 8, 4, 2, 1 half, 1 fourth, 1 eighth. And then underneath it, on the next line, I want you to write that. Now, just for this first part of this, I'm going to take out this, so we don't pay attention to it. And this shouldn't be too hard for you because you did a little exploration, just looked a little different. So, what do we do to get from the 16 to the 8? What do we have to do to the 16? Marlon? Divide it by 2, or you could say subtract 8, right? But we actually happen to divide by 2, and you'll see why in a minute. To get from the 8 to the 4, what do we do? And divide by 2, because if we did it using subtraction, it would be minus 8 minus 4, and that's not a pattern, because it's different. So this is now establishing a pattern, and if we follow the pattern, we divide by 2, we've established a pattern, okay? Now what I've written here is another way to write 16. 2 to the 4th power is 16. Just like 4 quarters, Kyle, is the same thing as $1, right? 2 different ways to say the same thing. 2 different ways to say the same thing. 2 times 2 times 2 times 2 is 16. This is another way to write 8, 2 to the 3rd power. But what did we do to this expression to change it into that expression? What did we do, Kayla? Subtract 1. Ah, very important part. Subtract 1 from the exponent, right? And what did we do to go from here to here? Cameron?
Subtract the exponent by 1.
Subtract the exponent by 1. And so we follow the pattern, subtract the exponent by 1, we get the power that's equal to that value. So that's what's happening is we're matching this pattern to this pattern. 2 different patterns, but they match because this value will be this one. This value is this one. This value will be this one. This is equal to this. So now we can use the pattern to get what would have to go right there to be equal to that. What would have to go right there, Danielle? 2 to the 0 power. So 2 to the 4th is 16, 2 to the 3rd is 8, 2 to the 2nd is 4, 2 to the 1st is 2. All of that conceptually makes perfect sense. 2 to the 0 power equals 1. Conceptually doesn't make sense. However, if we follow the pattern, you see that it does work. But does it work every time? So now I want you to put your pencil down, but when I say put your pencil down, that means double focus up here. So does this work every time? So now let's look here, and let me get rid of this for a moment. All eyes up here, all brains on high level, beast mode. So what do we do to the 81 to get the 27? This we haven't seen before. Janae? Okay. See if you can use what we've experienced so far to figure it out. I know I put some pressure on you. It's okay. There's lots of people that want to take over, so I'll come back to you for the next one. Okay, essence? Okay, so we divide by 3. 81 divided by 3 is 27. So now, Danae, how do we get from the 27 to the 9? Divide by 3. Very good. And so if you pay attention, you see that it's the same pattern over and over again. Divide by 3 and then divide by 3. Now let's establish the pattern here. This is another way to say 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. So these powers are equal to the value that's above them. So what did we do to get from the 3/4 to the 3 to the 4th to the 3 to the 3rd, Raquel? Subtract 1 from the exponent. Subtract 1 from the exponent. Subtract 1 from the exponent. What would have to go right here to follow the pattern and equal that number? Kiara? 3 to the 0 power. And so I could go on and on. I mean, I have another example down here, but I don't need to do it. What do you think's going to go right here in this spot? If you've been paying attention at all, and I know now Danae is. Go ahead.
10 to the 0.
So 10 to the 0 power will fit the pattern, right? Which means that 10 to the 0 power equals 1. 3 to the 0 power equals 1. 2 to the 0 power equals 1. Now you should understand why I wrote it this way. Anything to the 0 power is 1, no matter what it is. In fact, I could go wacky crazy and I could write this. Okay, watch. I could write negative 216 z to the 4th, x to the 3rd, y to the 18th, a to the negative 8th, and I do this. And what's that whole thing going to equal? Whole thing's going to equal 1. Doesn't matter. Doesn't even matter what this is or what it means. It's going to equal 1. Could do wacky crazy. 18 over s to the 43rd power. That's unusual looking, but if I just go like this, it's going to equal 1. Doesn't matter. Okay? Any questions? Any concerns? Good. So that's the easy part of the day. Now let's talk about a negative exponent. A negative exponent does not mean what you think it would mean. So we're going to spend a lot of time talking about what it's not. A negative exponent technically means reciprocal. I'm going to teach you a simple way to deal with it. I want you to be successful. And so I'm going to teach you a method to help you be highly successful. But if you ignore what I'm teaching you and you just design your own method, you will probably mess it up. So here's the technical part. Anything to a negative power does not mean multiply them. It doesn't mean take this and make it negative. It means it's the reciprocal and then you change the exponent to positive. Very confusing. Visually, mentally, it's very confusing. So here's a concrete example. 5 to the negative third power really means 1 over 5 to the positive third power. And then if you do 5 to the third power, 5 times 5 times 5 is 125. Okay? So let me clear up that 5 to the negative third, and here's where I'm going to do in orange. 5 to the negative third does not equal negative 125. And it does not equal negative 15. Okay? That's what it does not equal. So you have to, it's going to be a bit of a struggle. Does not equal those things. X to the negative 6th power does not equal negative 6x or x minus 6 or anything else that you can make up. It means the reciprocal of it. So now I'm going to teach you the easy way to deal with it, okay? Well, I shouldn't say easy. The simple idea is that think of the word negative, and we're going to use it to describe emotion. You're feeling negative. You don't feel very good, right? Sometimes when you don't feel very good, you take a break and you go somewhere else, okay? If I'm not doing well in my job right here, I may be feeling negative. I may step outside the door for a moment just to take a breath and maybe try to get more positive, right? Isn't that the opposite? If you're feeling negative, don't you want to feel positive? So here's what I'm going to say to you, is that in your mind, you have to see 2 rooms. The numerator is a room and the denominator is a room. Right now, this is in the numerator, of course, because there's always a 1 underneath. But he's feeling very negative. Feeling very negative means that we have to help him feel better, and we have to move them to a different room. And the only other room available is downstairs. So to make him feel better, we're going to move him downstairs and turn him positive. Because now he's at a break, now he feels more positive, okay? So this is over 1. That's the upstairs, that's downstairs, but he's feeling very negative. So we're going to move him downstairs and turn him more positive by giving him a break. And that's why he ends up downstairs. So now watch. What if he's already downstairs? If he's already downstairs and feeling negative, where should he go?
Upstairs.
Upstairs. So x to the negative 12 downstairs needs to feel more positive. He's got to go upstairs. So we're going to move him upstairs and help him feel more positive. Okay? It may sound a little silly and a little unusual, but it's a very effective way to remember what you have to do. So here's the basic idea. If you have a negative exponent, you don't want it. Negative exponents, we don't want them. So we change them by making them feel more positive. But you can't just change things. You have to follow rules and do things, okay? So that's the basic idea. If you don't get it yet, I don't blame you. So just take your time. So now we're going to kind of explore some different scenarios to see how it affects different types of expressions, okay? So we're going to start simple and build from there. So 4 to the negative 3rd power. He's feeling very negative. To feel better, needs to move to another room. But there are no rooms. I don't see any. Well, guess what? They're in your mind. It's right here. So sometimes you have to put the room in. And now we need to move him downstairs so that he will feel better. So he's going to move downstairs to feel better. And when you move him, he disappears from upstairs, ends up downstairs, and now feels better. Now, are you allowed to write this? Are you allowed to write just like that?
No.
So what's missing? What's missing? Marlon?
1.
Yeah, and so you know that there's got to be, if there's a fraction, there has to be something up top. So you have to put a 1 at least. And so this means 1 over 4 to the third power, and that's dealing with an exponent. I'm sorry, a negative exponent. So now we want to be able to also rewrite that to its actual value. And so now we can evaluate 4 to the third power either using mental math or using your calculator. 4 to the third power, Briante, you already did it? Oh, what is it? It's 64. So 4 to the negative third power actually equals 1 over 64. Any questions, Julianne?
So when it's at the top, is the answer gonna be like a fraction?
A lot of times, yes. Okay, wait till we see some more and then you'll get a better experience out of it, okay? Jamel and then Kyle?
Say if you have a problem, right? And then like say if there's already, let's say if there's a fraction there, and you have a negative square, you do like thinking.
Yeah, if the fraction's already there, and we'll see some like that, but just so you can see it here, if we did 4 to the negative third over 5, like that, the 5 stays. We don't touch the 5 because it's just a 5. This needs to move downstairs to feel better. So this would disappear, and we would put it on the bottom as 4 to the third power, and then we would put the 1 on top, and so we would end up with 1 over 5 times 4 to the third power. Okay? So I didn't want to get that complex yet, but that's basically what would happen, okay? Good. Kyle. Good. Good question. All right, part B. 7 to the 0 power. 7 to the 0 power. Yeah, there's nothing to do. It's just 1. 7 to the 0 power is just 1. Anything to the 0 power is 1. Any questions about that? Good. So let's now expand what we understand. Go to part C. Negative 5 to the negative 4th power. And here's where we need to start developing some rules and some understanding of what's going on and what is not part of this. Here's what happens to me every year. Is I introduce the idea of a negative exponent and students start doing wacky things. Students start going like this. Like 2 weeks from now, I'll give you a question that involves this. And all of a sudden, students will go like this. They start moving negative numbers. Students start lumping negative exponents and negative numbers together, and that's not the case. A negative number is a negative number. A negative exponent is a negative exponent. There's 2 different things going on. So you have to be aware of that. There's 2 different things. There's no simple way to say it. That's it. So this is a negative number. This is a negative exponent. What you're learning today is how to deal with negative exponents. Negative numbers you learned a long time ago. So negative 5 is the base. That doesn't matter. It could be an x, it could be a 20, it could be 100, it could be negative 1,000. It doesn't matter. All that matters right now is dealing with that negative exponent. And a negative exponent has to move to feel more positive. So this has to move downstairs to feel more positive. Nothing else changes except for the exponent. So don't change the negative 5 to a positive 5. The base is still the same, but now the exponent is feeling better and is now positive. So now we've got, on the bottom, negative 5 to the 4th power, and on top, as Marlon said, we have a 1. And now we can use our calculator to do negative 5 to the 4th power by typing in negative 5 times negative 5 times negative 5 times negative 5. What does it come out to? Got a couple people who got it? 4 people, 5 people, 6 people, 7 people? Go ahead, Kayla, what does it come out to? Yeah, it comes out to positive 625. Positive 625. So, negative 5 to the negative 4th power turned out to be 1 over 625. That's a little confusing. Where'd all those negatives go? They disappeared because they just did. Go ahead.
Okay, let's say like we have like a question like that, and what if like the bottom number still comes out of the number?
You're going to see that in a second. Okay? It's part D. Negative 5 to the negative 3rd power. Well, it's almost the same question. So you could apply what we did in C to this. It's a negative exponent. Oops, excuse me, I'm sorry. Negative exponent. So we need to help him feel better by moving him downstairs to take a break. It's going to disappear from here, and it will be negative 5 to the 3rd power. Now he's feeling more positive. And so here's what we end up with. 1 over negative 5 to the 3rd power. Now we can use our calculator to do negative 5 times negative 5 times negative 5. So what do we get for that? Give me a thumbs up when you got it. So I get lots of people who got it. Oh, we got a bunch of people who got it already. Okay. Kiara, what'd you get? Okay, so you get negative 125. So you have your choice. When you have a fraction where one of the numbers is negative, that's a negative fraction. So you can either leave it like this. I'm okay with that. The best way to write it is to move the negative sign outside of the fraction bar, and you put negative 1 over 125. But those are the same thing. Okay? So Juliana, I answered your question from before? Good. All right. Any comments, questions about zero exponents and negative exponents? Good. Well, we're on the path, so let's see if we can keep it going. You've got 4 different ones to do in this checkpoint. You got 4 questions. You got 2 minutes. It's really just 4 simple expressions to simplify. Let's see how we did. Color pens up. And this time it is a matter of what you're understanding now. Not a gotcha. It's not a big deal if you got something wrong. This is part of the learning process. But let's see how we did. Part A, what did you get? I got students 10 and 9. Student number 10, what'd you get?
1 over 10,000.
Student number 9, what'd you get?
1 over 10,000.
Correct answer is 1 over 10,000. Very good. I got 2 people who got it right. We'll see in a moment how we did with everybody. Part B, what'd you get? I got student 21 and student number 18. Student number 21. Okay, student number 18. So 2 students think it's 1 over 4, and it is. I got 2 students who got it right. That's good. Part C, I got students 17 and 4. Student 17, what'd you put? Student number 4, what'd you put? Okay, student number 13, what'd you put? One over negative 1 over 32, or if you put 1 over negative 32, that's the same thing. And part D, I got students 16 and 6. Student number 16, what'd you put? No, student number 16, I got student number 6 and student number 8. Student number 6, what'd you put? Student number 8, what'd you put? Of course, it's 1. Okay? So, there were 4 questions, but they were a little bit quicker. Give me a thumbs up if you got all 4 of them correct. Impressive. Most impressive. Put your thumbs down. Are there any questions? Jamel, do you know where you went wrong on part C?
Yes, I multiplied.
Too many times. You went all the way to 256.
Yes.
You multiplied way too many times. Here's a suggestion, and I still do it myself. Is especially if it's 2, is I just count on my fingers. 2 times 2 is 4 times 2, because this is telling you how many 2's to use. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now I've used 5 2's, okay? And that's what we had to do, is 5, okay? Any questions, comments, concerns? Good job. All right, so let's go next level. Evaluate the expression for the given value. And here's where algebra can be a little more interesting depending on how you feel about this type of thing, but now it gets a little bit puzzle-like. Puzzle-like in the sense that there's more than one way to do it, and it's kind of up to you to decide what path makes sense to you, as long as you're following rules and it's valid. So you could, for part A, you could first rewrite the expression with positive exponents and then evaluate it, or you could put in the 4 and then rewrite it. Either way is fine. It's really up to you to decide. I think it might make more sense to put the 4 in first and then work from there. So let's try that. Put the 4 in place of the x and we end up with this expression. At negative exponents, we don't want them. We got to make them feel better, move them to another room. So we're going to take 4 to the negative second, move them downstairs. So, going downstairs will disappear and will appear downstairs feeling more positive. As Marlon taught us, if you have a fraction, you need the 1 on top at least. So we have 1 over 4 to the second power. And now just do 4 to the second power, that's mental math. And so what do we end up with for this? Danae?
1 over 16.
You get 1 over 16. So evaluating this expression when x is 4 gets you that value. Any questions about that? Now part B, and here's the critical moment where you have to take everything together and you have to listen to my advice so that you are highly successful and you achieve that level 5 that I expected. We're going to put in the values that were given here in place of A and B. But don't write it like that. What are you going to do? Go ahead, Cameron.
Multiplication dots in between.
You're going to put multiplication dots in between because I'm going to show you in a minute what my students in the past have done, and I'm trying to help you avoid it. We do -2 times, and now A is 5, and it's being brought to the 0 power, so we put that. Times, and now B to the -4th power, but B is -3, so we're going to put that. Now we have a negative exponent, which means that we're going to need, bless you, we're going to need the upstairs and the downstairs. We need the upstairs and downstairs, so we need the downstairs here. And so now let's go one piece at a time. -2 is just a -2. Don't do anything with it. It's a negative number, it just sits there. What about, bless you, 5 to the 0 power? What can we do with 5 to the 0 power? We got a whole bunch of people who know, huh? And the whole thing is a 1, okay? So that's a 1. That's it. It's just a 1. Now this, what's got to happen to it? Okay? It's going to go downstairs and what? Very good. So this is going to go downstairs. It's going to disappear. The base stays the same, but the exponent feels more positive now. So let's make sure we see what's left. What's left on top is really just a -2 because -2 times 1 is -2. And on the bottom, we have this that we need to find the value of. And that's it. So let's find the value of that denominator. The top is going to be -2. And now do -3 to the 4th power, which is -3 times -3 times -3 times -3. There we go. Oh, what is it? It's 81. Is that right, Kiara? It's 81? Oh, okay, it's 81. It's 81. So this whole unusual looking expression with these values turns into that number. Anyone have any concerns or questions about that? Go. Go ahead. Yep. What is a big number? He's right. We need to simplify this. So let me take my circle away. We need to simplify that. Raquel? -1/9. How'd you do that?
Wait, no. That's wrong.
Okay. So if you wanted to say that this was -1/9, that means you divided the top by 9 and the bottom by 9, but that doesn't work. So unfortunately, it's already in simplest form. So Marlon, you're absolutely right. You have to simplify everything. Never have to even ask. Just simplify at the end. Okay? Good. We're doing quite well. Any concerns? All right. So checkpoint number 2. I want you to evaluate these two. And now you are going to prove to me how well you have digested today's material. You got 3 minutes for 2 questions. If you finish and there's still time left, then go ahead and compare your answers with your teammates to see how we did it. Yeah, because that's what we talked about at the beginning today, that it's all multiplied, rearrange it, and it's just like oh, it's oh, good goal. All right. So this was a little bit more challenging than the previous checkpoint, but we're still going to use the equity bars and just see how we did. And again, if you get something wrong, it's not a big deal. This is part of the learning process. But you do need to learn where you went wrong or what went wrong. So let's start with part A. And I've got student number 11, 4, and 13. Student number 11, what'd you get?
1/64.
Student number 4, what'd you get? Student number 13, what'd you get? So I've got 3 students who think that it's 1/64. Well, that's good. Got 3 of my students got it right. Part B was a little bit more challenging. What did we get? I got students 19, 18, and 2. Student number 19, what'd you put? Student number 18, what'd you put? Student number 2, what'd you put? So you all think that the answer is 2, and it is. Pretty impressive. So I know that I had at least a moderate amount of success with 6 students. Let's see how the rest of us did. Give me a thumbs up if you got both of them right. Okay, so I got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Put your thumbs down. Good, that's pretty impressive. So you should be proud of yourselves. That's no easy task. Does anyone have any questions on these? Anyone can't figure out where they went wrong or just something you're curious about? Go ahead.
I got 1/32.
1/32. Okay. So then the issue was dealing with the negative exponent. Did you put multiplication dots between everything when you wrote?
Yes.
Good. So you wrote 8 times. Now we've got -2 to the negative second power times, and now b is 6 to the 0 power. Is that what you wrote?
Yes.
So what'd you do next?
Then I got 8 times, then it would be 8 times 4, then you brought it downstairs.
So then how could it be 8 times 4 if you brought it downstairs?
I mean, because like that would be 4.
But it's not 4.
You have to bring them upstairs.
You got to bring it downstairs. He's upstairs right now.
Oh.
You got to bring him downstairs, and now downstairs it's -2 to the second power. So you're right, it's 4, but it's 4 downstairs.
Oh, I thought it was 4 upstairs.
Okay, so that's where
I
you.
thought it was negative 2 down.
Okay, so this is the idea. You see a negative exponent, move it to the other room immediately. Don't try to do it and then move it to the other room. Just move it immediately to the other room, okay? Good. I'm glad you asked. Any other comments or questions?
You said that there was a common mistake that your students always
Yes. So let me go back. Thank you for reminding me. So here's what my students in the past have done. They don't put multiplication dots. What happens is that it's very natural for your human brain to take the number and attach it to the letter in front of it. So a lot of my students take the -2 and they put it together with the 0, with the a to the 0 power. And then they say that that whole thing is 1, which is a mistake, because it's not. A to the 0 power is 1. The -2 is kind of separate from it. So the difference is, and I'm just going to come down here. Let me show you again. -2 a to the 0 power. If you rewrite it like this, I think it says something, it says the same thing, but I think your mind sees it differently. I think people tend to take the 0 and apply it to this whole thing, whereas here you can kind of see that, oh, well, this is -2. This is 1. -2 times 1 is -2. Okay? Does that make sense? So that's one of the major reasons why I encourage my students to put the multiplication dots in. Okay? So thank you for reminding me. I appreciate that. Any other comments, questions, observations? Okay? I'm short on time, and that's my fault, not yours. You guys have done a good job. So I'm going to hold off on this. You're going to see a couple of questions in your homework that are next level, higher level. You're going to do them. You're going to do the best that you can. If you follow everything that I've taught, you should have some success. Okay? But we'll talk. We're going to filter this in over the next lesson as well. All right? So I'm okay with it. So draw a line across your paper. Your homework is on page 325. You're going to do numbers 3 through 23. Some of them are very simple questions like 82 to the 0 power. That takes virtually no effort to do. But they're constant, practice. You gotta experience all this. I do have a quiz scheduled for next week. However, we have testing next week, so I don't exactly know when the quiz will be.